Greetings everyone. So in last lecture we got a file which was brainpan.exe. Now let me just go ahead and move to my desktop to show you. This was the file. I downloaded this file as a.exe. That's really fine. Now I also told you to download the immunity debugger or the OLE debugger, whichever you like. Both are exactly gonna work in the same way. So in this lecture we will try to see if this application is vulnerable to buffer overflow, and basically how do we do the overflow and how do we create a custom exploit to exploit the real machine, which was the brain pan. So we are going to assume that this machine, which is the Windows 10 right here, this is my lab environment, and we are going to try to hack our lab environment using our parrot.sec, and then once we develop the exploit, we will use that to crack the brain pan right here. Yeah, so that's the whole thing. Let's get started. Now when you run this application, let me do that for you, and here it is on my second desktop right here. When you run this application, it says it's running on port 9999. Now you just need the IP address of your lab machine, which is this one. In my case, this is 192.168.252.1. So when you just you can use basically anything. I'm just gonna use netcat here. When you use netcat and try to connect to this machine, so netcat and then just give the IP address 192.168.252.1 and space and then just give the port, so it is 9999. When I try to connect to this application, you can see I can connect here. Yep. And basically when I type anything like it says access denied, and you see right here it says copy this to buffer. What exactly is getting here? Most probably it's using the function called string copy, or it's using some bad functions like gets and all. Now you can do one thing. You can try to decompile the application. You can try to view the source of the application. Otherwise you can try to debug this application in debugger and see what exactly are the strings. But a very easy way is to try to simply overflow this and see if it crashes. So just for a proof of concept, if I just run that again, and just a second, and I think I need to close it and run it again. Let's run it again. Here is running right here. So if I do this again, and now if I just keep on sending anything like a, right, I'm just gonna send a lot of times. Just let me just get full screen just to make it easier. I'm just gonna copy this and paste it again and again. Okay, so if I just sent a lot of a's, right, I was gonna show you as a proof of concept right here. You see this application is running, but when I'm sending this, I'll just press enter here and this application will crash. I press enter, wait for some time and see what happens. You see, application automatically crashed. This is what it is telling us. This is a overflow. The application got overflowed, right? We flooded that application. It just got a shortage of memory. It was not able to handle everything, right? So that is why it got crashed. And this says that there is a buffer overflow possible. There's an overflow possible. You can do any kind of overflow, and buffer overflow, it's a huge topic. I can speak on hours on this, but to make it beginner friendly, we are going to use some templates which anyone can use. You don't need to learn Python. You don't need to learn any language. You can do overflows just like an expert just by using the templates. And when you just attend some official trainings like the OSCP training, like PWA course and all, you get the templates. You get the templates. You can use them. You get the scripts, just for the educational purposes. You can use those scripts. So what we did by sending a lot of A's, this is called as fuzzing. That program was supposing that he will get a password, but we sent a lot of data which it was not expecting. This is called fuzzing. We fuzzed that program with mal input. This a lot of A's, it was not expecting it'll get a lot of A's, and that is what we did right now. This program crashed in this small amount. you know, this is very small amount of A's we sent. This is too small, maybe some 1,000 A's. This was very small, right? But some programs may even take you 10,000 A's, right? It depends. So in such a cases, you cannot just go ahead and type A yourself. You can do this thing automatically by some, you can say by some scripts or some programs. A nice program here is Spike. You can use Spike to do this work for you, but that will become a little overwhelming for a lot of beginners. So I'm going to show you that with a Python script, and I'm going to explain you that script. So you know, you don't need to learn Python again, but I'll explain you that. Now I have multiple desktops here, so I'm going to open that program on my another desktop. Let me move that to another desktop. So I'll just move this program to my another desktop so that we can avoid getting, you know, out of virtual machine again and again. Okay, now here we are. Let me just clear the screen for you, and I have two files for you. 1.py, which is the fuzzer, and 2.py, which is the attacking script, the overflow script. So I'm gonna include both of these scripts. You can assume this as a buffer overflow kit, right? I'm gonna like add these scripts in the resources, so you can download that, and you can use them freely. They are open source scripts, you know, just the Python language. There's no copyright claim possible, right? So let me open the first script for you. This is the first script. What you need to understand here is buffer is what we are going to send. So you know, I sent that A. This is the same thing. You can add anything here, it doesn't matter. I just added a capital A, which is a industry standard. Then counter is how many A will it send. So I will start with 520. So this is like, you know, this is a script I was just testing up. A good industry standard is to keep your 100. Okay, 100, or you know, if you think it's a very big program, start with 500 or 1,000, depends, you know, what exactly you're trying. Buffer length, so how many tries it's gonna take. Let's come on this line later. First of all, understand it's gonna send A. It will send A 100 times. If it fails, it will send A 100, which is this one, plus how many? Let's keep it one more 100. So it will send 100A in the first time. If it fails, it will send 100 plus 100, 200A in the second time. If it again fails, it will send 200 plus 100, 300 A's in the third time. Again, if it fails, 300 plus 100, 400 A's, and so on. It'll keep on going, right? Now, how many times it will try? This variable will define. It will try, let's say 30 times, right? A simple, you know, this is very similar to the OSCP script. But I would again say I have not created the script. It is publicly open source, available on the internet, and you can download it from, you know, internet yourself. Just go to GitHub, search for some, you know, fuzzing script. You will easily get this, right? Then it's gonna just print fuzzing with dash 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 bytes. Now this is what we are interested in. We need to know how many characters we need to send to crash that application, right? And then it will connect on the application on this IP address. So you can, like, you will have to change this IP address according to yours. In my case, it is 192.168.252.1, which is my Windows lab IP. Then the port, so in this case it is 9999, right? You can change it for other applications, and this script will work in every case. Then if it, like, until it is working, until the application is working, it's going to give us the input, the output. When the application is failing to connect, it will say connection failed. That's all the script is going to do, right? So just to show you the script again, you will find the script in the resources, right? And it's going to use the interpreter as Python right here. So that's all. Now you understand, you don't need to learn Python. You can work with the predefined open source script. Let's say Control X, Y, and enter to save it, because this was nano. Let me clear the screen and let me open the brainpan.exe right here. So let's simply run that script. You know, we have defined everything in that. So I will say ./1.py, another option, Python space 1.py. So, you know, you can use anyway. And I press enter. And you see that crashed, right? So 1 byte to 100 bytes, 200 bytes, 300 bytes, 4, 5, 6, 7. It means the application crashed on 700A or before 700A, right? So maximum is 700, and this is what we are interested in. We just want to know what is the maximum limit, right? Let me clear the screen. And now that we know that the application is crashing before 700, we want to know what exactly is the byte size. So we just have an idea that okay, the range is 0 to 70. How much exact amount of bytes we need to send to crash the application? This is what we want to know, right? What is the exact amount of A or of bytes we will sending? So for that, we are going to use two other scripts that are called as the pattern create and pattern offset calculator, right? You can find them again on internet, and there are even websites like pattern create and pattern offset calculator. Just go ahead and search that. You will find online tools. But if you have Metasploit installed, you can use Metasploit framework scripts. I'm not saying we are going to use Metasploit. I'm saying we can use scripts out of that. So it's like you are not using Metasploit, you are just using some scripts out of it, and this is allowed in almost all exams. Even in OSCP you can use these scripts, right? So let's do that in the next lecture. In this lecture we just figure out that what is the amount of bytes and a range in which we can send to crash the application, and let's do that in the next lecture.